Good morning to all of you. I welcome you all for the morning session class. So in the Monday's session, I was discussing module 3, right? So it was the deadlocks concept. So in today's class, we will try to learn more related to our deadlock concept. Okay, so before that, I will share the slide to you. Right. So we have seen what to mean by a deadlock, right? It is a situation where when multiple processes wants to use the resources, okay? So then what happens? One process is holding a resource, okay? And it is requesting for an additional resource. Okay, like that kind of situation, every processes are using. They will be holding one resource and they will be requesting an additional resource. So in this case, no process is executing anything. So they are simply requesting for additional resources. They are not executing anything. So this results in deadlock. Okay, that is what we call it as a deadlock, right? So this is what the diagram we have seen in the last class, where there are two processes. One process is requesting some resource, and this process is already been allotted the resource R2. Okay, the same condition here also. Process P2 is requesting resource R2, and it is already holding resource R1. So here no processes P1 or P2 they are executing, so they are simply requesting for the resources. So this situation is called as deadlock, right? Okay, and we have learned some necessary conditions for deadlock. When a deadlock will occur in our system ಅಂತ ಹೆಂಗ್ ಹೇಳ್ತೀವಿ ಅಂತಂದ್ರೆ based on the four necessary conditions. So these are the four necessary conditions. So all these things has to occur, okay, in our system. Then only we say that our system is under deadlock anta helbodu now. So what are those four conditions? The first one is mutual exclusion anta. So we know mutual exclusion means only one process is allowed anta artha to execute anta allo. Same concept when I discuss in terms of deadlock. Mutual exclusion means, so we are keeping the resource in a non-shareable mode anta. So shareable mode ಅಂತಂದ್ರೆ ಏನು? n number of processes can use that resource anta. So no problem will occur. Okay, so if you keep a resource in a non-shareable mode, non-shareable ಅಂತಂದ್ರೆ, so that resource has to be used by only one process. Okay, so when one process is using, the other process has to do what? Waiting. Okay, so when that results in what? Deadlock occurrence in your system anta. So that is the first necessary condition for deadlock to occur, that is mutual exclusion. How you are achieving mutual exclusion? By making resources as non-shareable. That is very important. Okay, by making resources as non-shareable, you can create a mutual exclusion environment which results in a deadlock. Okay, that is what the first point says. Similarly, the second one is hold and wait. So hold and wait means one process is holding one resource and it is requesting for an additional resource. So in that situations also deadlock will going to occur anta. So third one is no preemption. No preemption ಅಂತಂತಂದ್ರೆ, so you are not forcefully removing the resources from the process. So the process has to voluntarily release the resource. Okay, until the process will not release the resource, the other program or a process will not going to get this resource anta. So it means it has to keep on waiting until this program releases it. So which in turn results in what? Deadlock occurrence anta. That is what no preemption indicates. So last one is a circular wait anta. So it will be in an order. One process is holding a resource and it is requesting for its next process resource. Similarly, one process holding a resource and it is requesting for the next process resource. Like that, it will be in a circular fashion. All programs will be waiting. So this one once again results in what? Deadlock anta. So all the four conditions has to simultaneously occur in our system. Then only we say that our system is under deadlock anta helbodu, right? So these were the things which we learned as an introduction concept in the last class. Okay, so in the today's session we will learn the new concepts, that is resource allocation graph. So you might get a question, what to mean by resource allocation graph anta kelbodu. We know what is a graph, right? So graph is nothing but a collection of uh, uh, vertices and edges anta. We have learned this concept in your previous semester DMS ಓದ್ಬೇಕಾದ್ರೆ ಓದಿದ್ವಿ ಅಲ್ವಾ ನಾವು. ಗ್ರಾಫ್ ಅಂತಂದ್ರೆ it is a collection of vertices and edges. Okay, so vertices ಅಂತಂದ್ರೆ ಯಾವುದು? in terms of computers ಅಲ್ಲಿ vertices ಅಂತಂದ್ರೆ ನಾವು we call them as processes. Okay, and we call them as resources. ಇವೆಲ್ಲದನ್ನು ನಾವು vertices ಅಂತ ಕರಿತೀವಿ. Okay, you can see that here. Vertices are of two types. One is your process, okay, and the another one is your resource. Okay, so there are three processes here, and there are four resources: R1, R2, R3, R4, correct? We call them all these as vertices anta karitivi. Similarly, and you can see the arrow mark symbols, correct? These arrow mark symbols indicates the edges. So this entire diagram, what you can see in the right part of your slide, is resource allocation graph. Now what does this says antandre? It is a collection of group of processes and resources where there is an edge from one process to a resource, and similarly there is an edge from one resource to a process. Okay, so ಏನದು? Let us understand that one. So a directed edge, okay, from ಎಲ್ಲಿಂದ? From process pi to resource rj. Okay, ಇಲ್ಲಿ ನೋಡಿ, from process p1 to resource r1 there is an edge, correct? So if there is an edge from process to resource, then we call that edge as request edge anta karitivi. Okay, it means process p1 is requesting for the resource r1 anta artha. Similarly, one more edge you can see in this resource allocation graph. So that is an edge from the resource rj to process pi. So in this example you can see there is an edge from resource r1 to p2, correct? Now we call this edge as what? Assignment edge anta, andre allotted anta, andre ಆ ರಿಸೋರ್ಸ್ ಆ process ಗೆ allot ಆಗಿದೆ ಅಂತ. We have allotted that resource to the particular process anta. That is why it is called as assignment edge. Okay, clear with this? So this is your resource allocation graph. It contains a set of vertices called processes and resources, and it will be containing set of edges called request edge and assignment edge. So this entire thing is called as resource allocation graph. Okay, clear with this? Now the next thing is about instances. So you can observe this particular diagram. Can you see a dot symbol here? Kanta idena? Please unmute yourself and tell. Can you see the dot symbol here in resource type R1?
Yes, sir.
Okay, now what does this indicates antandre? Instance anta. Okay, so how many of resource R1 we have anta artha. Okay, so one dot ide antandre en artha? Can you tell what does one dot indicates?
One instance is present.
Right, so one dot indicates we have only one instance of that resource type anta artha. What is the resource type here? R1. So we have only one instance of the resource type R1 anta. Similarly, you can observe here R2. How many dots you can see here? There are two dots. It means there are two instances of that particular resource anta artha. Similarly, you can observe the resource 4. How many instances we have? There are three instances of resource R4 anta. So just for an example sake, I will take R1 ಅಂತಂದ್ರೆ I will call it as CPU ಅಂತ ಕರಿತೀನಿ. Okay, so one dot antandreno, how many CPUs we have? R1 indicates CPU resource anta. How many CPUs we have here?
1.
1. That's it. Okay, similarly observe, I will call resource R4 as a printer. Okay, so how many printers we have in our system? How many printers are there in our system? R4 indicates printer resource. Okay, so 3 dots indicates what what it means. There are 3 printers available in the system anta artha. Okay, fine. Next, observe resource R2. I will take example of R2 as say your RAM memory. Correct. So 2 dots indicates what? There are 2 RAM available anta artha. That's what that indicates. 2 dots indicates. So dots means instances anta. How many of such resource types are available in your system anta artha. Okay. So that's what it is highlighted in the last point. So resource R1 and R3, we have only one instances available, whereas resource R2, we have 2 instances, and resource R4, we have 3 instances available. Okay. Okay. Next. So according to the diagram, you can see here, process P1 is requesting resource R1. So that's why there is a line from process to resource. Similarly, resource R1 is allotted to process P2. So that's why there is an edge from R1 to P2. So like that, you can understand this particular diagram, where are the resource request edges present and where all the assignment edges are present. Okay, so please, can anybody unmute and tell how many request edges are present here in the given diagram? How many request edges are present? Please unmute yourself and tell in this diagram. How many request edges are there in this diagram?
2.
2. What are those? Can you tell?
P1 to R1 and P2 to R3.
Correct. So there are 2 request edges. You can see P1 to R1 and P2 to R3. Whereas remaining are all what edges?
Assignment edge.
Yes, assignment edges. You can see R1 to P2, R3 to P3, R2 to P1, and R2 to P2. Okay, so since we have 2 instances of resource, okay, it means, so one instance you can give to one process and another instance you can give to another process anta. Okay, if we had only one instance of resource R2, then this 2 edges were not possible. Yakandre onde one instance irado, so we cannot give that one instance to 2 processes. It is not at all possible. Okay, that's why since we have 2 instances of resource R2, that resource can be given to 2 processes anta. Okay, similarly you can observe here resource R4. Okay, so for how many processes this resource can be allotted? Can anybody tell? For how many processes resource R4 can be allotted? Can anybody tell?
3.
3. Correct, because we have 3 instances of resource R4. Okay, so one instance you can give for P1, another instance you can give for P2, and the last instance you can give for P3. And like that you can distribute the resources. Okay, but resource R1 and R3, you can observe there is only one instance present. Okay, you have to be giving this resource to only one process. That's it. Okay, so that is the overall idea behind this particular resource allocation graph. diagram. Okay, hope it is understood to all of you. Okay, the next and important thing is, why do we need to construct a resource allocation graph? That is important. So you can get a question, what is a resource allocation graph and what is the necessity of creating a resource allocation graph? Yake create ಮಾಡಬೇಕು? So the reason behind constructing a resource allocation graph is to check whether if the resources are allocated according to this graph, whether deadlock will occur or not ಅಂತ ಚೆಕ್ ಮಾಡಕ್ಕೋಸ್ಕರ ನಾವು allocation graph ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, so the graph will tell how we are going to allocate the resources to the processes. Okay, after allocating these, whether deadlock occurs or not, we have to check using the resource allocation graph. Now, how we are going to do that one antandre, if there is any cycle formation, okay, occurs in the constructed graph, then we can easily say that the graph results in deadlock, means our system may encounters deadlock anta artha. Okay, if there is any cycle formation. Okay, so this is an example I have taken. So you just tell me whether there is any cycle formation here in the given graph. Unmute yourself and tell whether there is any cycle formation in your graph. Do we find any cycle formations here in the graph? So there is no cycle formations, correct? So we can easily say that deadlock is not occurring in our system. We can easily say, okay, if we allocate resources and if we request resources in this order, what you can see in the diagram, in this order, if we request resource and if we allocate the resources to the process, then deadlock will never occur anta helta idivi. Okay, now let us understand with this concept of deadlock using another example. Okay, observe this diagram, what I can able to see here. So what the point says, if a graph contains no cycles, what it says, then no processes in the system is deadlocked anta artha. Okay, so there is no chance of deadlock occurrence anta. Clear? Okay, so you'll notice the what does this particular diagram says antandre, there are two resources present and there are two processes present. Okay, and we have only one instance present in each resources, correct? Resource R1 is also having only one instance because there is only one dot present. Can you see? Similarly, resource R2 also contains only one instance. In these cases, the deadlock occurrence is more, correct? Because you don't have multiple instances. Okay, one instance, if it is some resources process is holding, means other process cannot request it. If it is doing, then it results in a deadlock anta. Okay, so can you see there is any cycle formations here? Please unmute yourself and tell, do you find any cycle formations in the given graph?
Yes, sir.
So yes, the cycle formation is, you can observe P1 to R1, R1 to P2, P2 to R2, and R2 to P1. So this is called as cycle. So you can see that edge I have written here in the rectangular box. Okay, and it is highlighted also. So this is an edge which results in a cycle formation. Okay, and I told whenever there is any cycle formations, okay, then the deadlock will occur anta artha. If there is no cycle formation, means then the deadlock will not occur or the deadlock will not exist in our system anta artha. That's what this diagram is trying to say. Now observe the second point in the slide. What second point says, if resource type have multiple instances iddaga, even though if we get a cycle in the graph, then deadlock has not occurred. Okay, that's what that indicates. Okay, multiple instances there are chances that, so even though if there is any cycle formation, there are chances that one process may release the resource after some time anta. Okay, but here there is no such concept is occurring. There is only one resource present. No process will release the resource until it gets the resource from the other process. So here deadlock will always occur when you have single instances, but in multiple instances deadlock may not occur or deadlock may occur. So you cannot guarantee here. So that is a better way of using resources, you by having or by keeping multiple instances in your system. So to explain that, there is one more diagram I have taken. Observe this. So can you see the cycle formation in this particular graph?
Yes, sir.
Yes. So you can see P1 to R1, R1 to P2, P2 to R2, and R2 to P1. So there is a cycle. So whenever cycle occurs, I told deadlock will occur anta helide. But here deadlock will not occur. Why I will justify my answer. The answer is we have multiple instances of resources. Can you see? We have two instances of resource R1 anta. Okay. Similarly, we have two instances of resource R2 anta. Now observe this carefully. Process P2 is requesting resource R2. Correct. According to this diagram, you can see one instance of resource R2 is allotted to P1. Okay, similarly, another instance of resource R2 is allotted to P4. Okay, if any of the one process, okay, either P1 or P4, either P1 or P4, if it release the resource, then what happens? There will be no chance of deadlock, correct? If it release the resource, there is no chance of deadlock, correct? So that's why whenever you have multiple instances of resources, even though if you get cycle in the deadlock graph, deadlock may not exist in your system anta. That's what this particular diagram is trying to tell. So that's what I have highlighted in this particular point also. So what is the point I am saying here? Resource type has multiple instances, and also the graph is having a cycle. But deadlock is not occurring here. Why? Because P4 may release the resource R2 after some time. If P4 release or P1 releases after some time, then that resource will be again allotted to which process? Process P2, which because it was requesting, correct? So that can be allotted. So then it will break that particular cycle anta artha, correct? Is it clear with this concept? So that's how whenever you have multiple instances of resources, the chances of deadlock will be very much less. But whenever you have like this, whenever you have single instances of resources, then deadlock will occur in your systems. That's what this indicates. So if they ask in your examination, explain how the deadlock can be detected using resource allocation graph antantandre, you have to explain like this by writing this particular diagram, and you have to explain. So how deadlock will occur when you are using single instances, and how deadlock will not occur when you are using multiple instances of resources anta. Okay, hope it is clear to all of you. Fine, right? That is all about your resource allocation graphs. So next thing is methods for handling the deadlocks. So if at all deadlock has occurred in your system, then how do we avoid this deadlock situations anta? Okay, so how do we manage or handle the deadlock situations anta? So let us understand that one. So observe the first point. So all these things we are learning in our chapter. Okay, So we are having certain protocols here, okay, which will try to prevent our system from entering the deadlock state. That is one method. Or we have certain protocols available for avoiding the deadlock from getting occurred in the system. That is the first point says. So we can use the protocol to prevent or avoid the deadlock in a system. That is first one. Second one is, what does the second way of handling the deadlock ಏನಂತಂದ್ರೆ, allow your system to enter the deadlock state. Once your system is entered the deadlock state, you try to detect that particular deadlock and recover from that particular deadlock state. That is the second way of handling the deadlock situations. Am I clear with this? First situation is, we can use the protocols to prevent or to avoid the deadlock situations. Okay. Second one is, we allow the system to enter the deadlock state, detect where deadlock has occurred, and try to recover from deadlock. That is the second method. The third method is, okay, which most of the operating systems you can see here. Okay, the third solution is used by most of our operating systems in modern operating systems. Maybe your Unix irbodu illa Windows irbodu. Okay, most of the modern operating systems use this solution. You know, it will try to ignore the deadlock occurrence in our system. Okay, even though deadlock has occurred, it will try to ignore that particular fact that deadlock has occurred in our system. Anta. By that, you try to handle the situations. Clear with this? So these are the three important ways in which you can handle the deadlock situations. Fine. So we will see one by one these algorithms, okay, or protocols in the upcoming sessions of deadlocks. So we will see the very first one, deadlock prevention. How do we do deadlock prevention? Anta. Okay. Or how do you prevent our system from deadlock? Okay, we will see that one in the heading deadlock prevention. Okay, so you can get a question, explain how the deadlock can be prevented in our system anta kelbodu. So to understand this, we must know the four important or necessary conditions for deadlock occurrence. ಈಗ ಡೆಡ್ಲಾಕ್ ನಮ್ಮ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಅಕ್ಕರ್ ಆಗ್ಬೇಕು ಅಂತಂದ್ರೆ there are four important conditions. Can anybody tell what are those four important conditions for deadlock occurrence? Unmute yourself and tell. What are the four necessary conditions for deadlock occurrence?
Mutual exclusion, hold and wait, no preemption, circular wait.
Yeah, right, correct. So these are the four necessary conditions which has to occur in our system. Then only we say our system is under deadlock state anta. Okay, ಈಗ ನಾನು ಪ್ರಿವೆಂಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? It is an that is what the answer it is. Answer ಏನು? These conditions should not occur in our system ಅಂತ ನಾವು ತೋರಿಸಬೇಕು. Okay, means these conditions should not hold in our system. Then only we can able to prevent our system from getting into the deadlock state anta. Correct? That's what the first point is highlighted in your slide. ಏನ್ ಹೇಳ್ತಾ ಇದೆ? Deadlock occurs only if all the four conditions satisfy or all the four conditions holds ಅಂತ. ಈಗ ನಾನು ಡೆಡ್ಲಾಕ್ ಅಕ್ಕರ್ ಆಗ್ಬಾರ್ದು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಟು ಪ್ರಿವೆಂಟ್ ಏನ್ ಮಾಡ್ಬೇಕು ನಾನು? ಎನಿ ಆಫ್ ದೀಸ್ ಕಂಡೀಷನ್ಸ್ should not satisfy ಅಂತ ತೋರಿಸ್ಬೇಕು ನಾನು. Okay, let us understand that one, how we are showing that one ಅಂತ. So the first one is mutual exclusion. So mutual exclusion ಅಂತಂದ್ರೆ ಏನು? We were using resource in non-shareable mode ಅಲ್ವಾ? Non-shareable mode ಅಂದ್ರೆ only one process is allowed to use the resource because it is non-shareable. Okay, then it results in what? Deadlock ಆಗ್ತಾ ಇತ್ತು. ಈಗ ಡೆಡ್ಲಾಕ್ ಆಗ್ಬಾರ್ದು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ನಾನು? What we have to do? We have to make the resource as shareable. Instead of keeping it in a non-shareable mode, we will keep the resource in shareable mode. If we keep the resource in shareable mode, then what happens? N number of processes can use that resource at the same time. then there is no chance of what? Mutual exclusion. Mutual exclusion ಏನು ಹೇಳುತ್ತೆ? Only one process is allowed to use ಅಂತ. Okay. So if you keep your resource in shareable mode, then what happens? So you are allowing many processes to use your resource same time. Then this mutual exclusion will not satisfy anta. Okay. So if mutual exclusion is not satisfying means your deadlock will never occur in your system anta. So that's how you are preventing the deadlock. Okay, that is one. Second thing, hold and wait. Hold and wait andre eno? We usually hold one resource and we request additional resource. That's what we normally do. Okay. This results in deadlock. So ಇದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು? Okay, we try to use two kinds of protocols here. One protocol, what it will do? Okay, so one protocol is each process when it requests a resource, okay, so it process will be allotted all the resources, okay, before it starts or before it begins its execution. ಇವಾಗ ಏನಾಗುತ್ತೆ? When all the resources are used by only one process, okay, then no other process will hold the resources, correct? So then hold and wait will never occur ಅಂತ ಅರ್ಥ. ಕರೆಕ್ಟ್? ಏನ್ ಮಾಡ್ತಾ ಇದೀನಿ ನಾನು? This is one method of avoiding hold and wait. What I am doing here, I am making all the resources to be given to only one process. By that we are avoiding the holding of resources by the other processes anta artha. Correct? So the another method of avoiding hold and wait is what antandre, okay, so when a process requests a resource, okay, another process protocol is will allow a process to request a resource only when it is having nothing in it anta. Means whenever it is not holding any resources, then only you are allowing that process to send the request for resources. Okay, if I am holding one resource, then I cannot able to send the request for other new resource. So that is what the another way we can avoid the hold and wait property. Okay, so that's how you can prevent the deadlock occurrence. Either you allocate all the resources to one process, okay, then you can prevent hold and wait, or you cannot allow a process to send a request until it is not holding anything with it. Okay, by that we are avoiding hold and wait anta artha. Okay, great, that is a solution. Next, third one is no preemption. So no preemption ಅಂತಂದ್ರೆ ಏನು? We are not forcefully removing the resources from the process. Okay, so the program has to voluntarily release it. That's what it says. Okay, so here what we are going to do ಅಂತಂದ್ರೆ, so to make this condition does not satisfy, what we are doing, the first thing is, if a process is holding some resource, okay, and request another resource that cannot be immediately allotted, aವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ ನೀವು? Then all the resources which that process, ಯಾವುದು? The process which has sent the request, okay, has to be removed from that one. That is a one solution. Okay, see, if the session ends, please try to log in again. Okay, I repeat, if the session ends, please try to log in again. Okay, so what is the first solution for avoiding no preemption is, when any process is requesting for a resource, and if that resource is not been allotted, then what happens? All the resources which it has holding earlier will be released. Okay, that's what the first condition says, or will be preempted. That's how you are avoiding no preemption anta. Second solution is what? That is the second point. So this is the second point.